So this is actually lesson 16 here. That's the sheet you guys have here. And we're going to talk about molar mass today. So again, you're going to need periodic tables and calculators, don't forget. Molar mass. So what is the molar mass? Well, the molar mass of a substance is the mass in grams of 1 mole of a substance, 6.02 times 10 to the 23 particles of that substance. The symbol for molar mass is big M, and the units are something called grams per mole. Okay, so we'll take a look at this, and I'll show you what this means as we go here, what this is actually saying. Okay, so once we get to our first example, I'll show you that. Okay, so the molar mass of an element is the average mass in grams of 1 mole of the of atoms of that element. The atomic molar mass of an element can be found in the periodic table. And to determine the molar mass of a compound, we're going to take the sum of the molar masses of each atom. Okay, so we're going to go through a little example here, lithium. Okay, so we're going to look on our periodic tables. We're going to find lithium. Let's do that now. And in the top left, of course, we have the number of protons. Yes, lithium has how many protons again? Huh? 3. And of course, it'd have 3 electrons, yes. And we'd have, how many neutrons would it have, just for a little review skis? 4, yes, because it's got a weight of 6.98, so we'd say 7, yes. That weight of 6.98, that's the molar mass, okay? So that is the molar mass of that element, 6.98. So, what? 6.94, sorry. 6.94. So we're just going to write in here 6.94 grams, and we're going to use these units here, grams per mole, okay? And that number is an average of all the lithiums that we possibly have. Remember, we talked about isotopes at the beginning of the year. We talked about lithium comes in many different forms, okay? All I can tell you right now, before you move on, don't worry, okay? Just relax for a second. All I can tell you is that the most common one, of course, has 3 protons and 4 neutrons, yes, because that's the one on the periodic table, has a weight to 7, yes, 6.98. There's probably some that are less than that, so some probably have 3 protons and 3 neutrons, and we average those, right? And on average, they have a weight of about 6.94, okay, grams per mole, okay, good? Okay, what does this mean, okay? What does this exactly mean? Well, what they're saying is this. Remember, a mole, okay, the reason we talked about a mole the other day is because a mole is 6.02 times 10 to the 23, yes? And that's ridiculous to write that out every time. So we say, hey, 1 mole is this number, 6.02 times 10 to the 23. So if I took, let's do this. If I took lithium atoms and I put them on a scale and I gathered up 6.02 times 10 to the 23 lithium atoms, and I put them on a scale, so I count them out, okay? If you're really bad in this class, I make you do that. A little early, eh? Okay. It's funny because it's a really big number. Oy. Hey, this is going to go well today. If you counted out 6.02 times 10 to the 23 lithium atoms and you put them on a scale, okay, the scale would read 6.94 grams, okay? That's what it's saying. You take 602 sextillion lithium atoms, put them on a scale, the scale will say 6.94 grams, okay? Another way to say that is, again, if you took, I'm just going to do it down here. Don't think that I'm not doing this yet. I'll come back to that. If you took 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, if you took that many lithium atoms and you put them on a scale, it would read, again, 6.94 grams for every that many lithium atoms, okay? Good? That's what it means. But we're not going to write this out every time. That's ridiculous. We're not going to write out 21 zeros. And we're not going to write out 6.02 times 10 to the 23 when we already know that that's a mole. So it's the same thing as saying 6.94 grams per 1 mole, right? For every mole, I'd have a weight to 6.94 grams. Yes, on average. Does that make sense? Yes or no? Mm-hmm. Okay. Now, of course, every element here weighs something different because every element has more protons and more neutrons in some cases, right? Except for hydrogen and helium, but every element is going to weigh a little different because it's got a different number of protons and a different number of neutrons. So when we go to do carbon, okay, let's look up carbon, find carbon. It weighs, of course, the molar mass of carbon is 12.01 grams for every 6.02 times 10 to the 23 of those, or for every mole, okay? Again, these numbers you can find in the top right of your periodic table. So find carbon and look in the top right number, and it's 12.01 grams per mole, okay? This one's a little trickier. What do I have to remember about hydrogen gas? Yep. Yeah, they come in twos, right? So when we talk about hydrogen gas, we have to remember that, or fluorine gas, or nitrogen, or oxygen, or chlorine, we have to remember that they come in twos. So what's 2? Well, it's 1.01 for one of them, grams per mole, and it's 1.01 for the other one, yes? So we're going to add those 2 hydrogens together, okay? And the hydrogen in the air right now would have a mass of, a molar mass of 2.02 grams per mole. Okay, good. So we would take those numbers and add them together, or you can multiply it by 2 if you want, whatever. Yep. What do you mean? Well, no, this is fine for this one, but we'll get to that right away here. Okay. Now, the next option, is that good? Everyone, any questions? Because this is kind of a big part here. We have to be able to do this. Okay. Not only this year, but for the rest of your lives now. Did you guys do this before? Oh. Well, yeah, we're learning new stuff again. Okay. Cohen did. You did this before. All right. So what if you have a compound? Well, we're going to add up the individual atoms. Look, if carbon weighs 12.01, okay, and we got some hydrogens there. This example is there. My subscripts don't go down, of course. But, you know, if you got this compound here, we're just going to add up the individual atoms. So for this right here, I'd say, yeah, that's for the first one anyway. What do we got? We got 1 carbon, yes? So basically 1 carbon. And we're going to add on to that 4 more hydrogens, yes? So we're basically adding those 2 numbers together. So if you want to write that out, by all means, that's not probably a bad thing right now. So we're going to take 1 times 12 point, oopsies, I scrunched that in a little too far. 1 times 12.01 grams per mole. And again, these are coming from the top right of the periodic table, okay, in the little squares. 1 times 12.01, so there's 1 carbon, and there's 4 hydrogens. So I'm going to take 4 times 1.01 grams per mole. And I'm going to add that up together, okay? The important thing here is that we add up the elements. So think of it this way. It's 1 carbon and a hydrogen and a hydrogen and a hydrogen and a hydrogen, yes? We're not multiplying in between these 2 because that's going to get crazy. We're going to get molar masses of 5 bajillion, okay? We're adding all these elements up, basically. In this compound, I have 1 carbon and 4 hydrogens. I'm adding all that up, okay? And of course, you know, let's get the big calculator out. Why not? I'm just throwing it off right now, basically. That's all I'm doing. So, you know, we're going to take, well, I don't think we need to do that, but 1 times 12.01, or just basically 12.01, and 4 times 1.01, and we should get 16.05. So this compound, again, what does that mean? Well, now, if I had a mole of this compound, if I had 602 sextillion molecules of CH4, I got them all together, I round them all up, and I put them on the scale would read 16.05 grams, okay? That's, you know, like I said, these atoms are incredibly tiny, right? We need a big number. We need moles of this in order to have it register on the scale. Like the smallest atom we have is what? What's the smallest atom? Hydrogen. we need 602 sextillion of them in order for the scale to read 1.01, right? 1 gram. We need 602 of them, sextillion, lots. So that's kind of where this kind of whole idea comes from, right? What's a number that we can actually start weighing some stuff? I mean, obviously we can weigh less than a gram, but that's kind of the whole idea, okay? What's the molar mass of water? Well, I guess the first thing we need to know is what is the formula for water, yeah? Because obviously this is where that's going to come into play, which is what? H to the 2 to the O, yo, okay? So we got this, right? So well, how many hydrogens do we need? 2. So I'm going to put that down. And oxygen, we need an oxygen, right? What's oxygen? 16. So I'm just going to add on 16 grams per mole, okay? Make sure you use units as well, please, okay? So when we add all this up here, we should get what, 18.02 grams per mole. Make sure you have units here, 18.02 grams per mole. That's the units to go with this, okay? If you just put 18.02 grams, that's, I don't know what that is now, okay? We have to have 18.02 grams per mole, okay? And then again, we get into this question here. Well, now it's magnesium nitrate, right? So first things first, if I want to know the molar mass, that's what it's called, the molar mass, and we have to make sure we know what terms these are. By the way, it's represented by a big M, okay? We're going to look at a formula here coming up. It's represented by big M. Well, what's the formula for magnesium nitrate, I guess would be the first thing. Go ahead and do that. I'll give you a second here. Write that down. Okay, so magnesium, you're going to look that up, nitrate, right? Magnesium's a 2+. Nitrate, of course, this goes back to naming ionic compounds and writing formulas and all that. Nitrate's a 1-. We need to swap and drop. We need to come up with the formula for this. This is, of course, the 2 ions that are involved. So when I swap and drop, I'm going to get this. Now, again, you cannot forget the brackets here, right? We need to have brackets, because if we don't have brackets, well, again, you know, the 2 comes over and down. If I just put a 2 here, that doesn't make sense, right? And the 1 comes over and down, right? We don't write the 1. So we're going to go back to naming compounds again here, and that's going to be important, or writing formulas. So how many magnesiums do I have in this formula? I want you to think about this for a second. How many? 1, okay? So I'm actually just going to write this out just for now. 1 magnesium, and I'm going to add on to that. How many nitrogens do I have? 2, okay? This 2, remember, goes to everything inside the brackets, yes? So 2 times nitrogen. How many oxygens do I have? 6, okay? O3 and O3, so I have 6 altogether. 6 times O, oxygen, that's an O, okay? So maybe just write that down real quick, just so you kind of remember that for when you get to the homework part, so that you know. Magnesium is what, 24.31? Again, you're going to look these up on the periodic table. Nitrogen's 14.01. And oxygen, oops, sorry, and I need to add on to that. 6 times 16, yes? Oh, I should mention something else too. Actually, this is a good thing. I just remembered that. I should have mentioned this before. So we're going to add all that up, yes? Grab a calculator. There we go. What did I say? 24.31 and 2, well, yeah, sure, I'll just do it. 2 times 14.01, which would be 28.02, and 96, I guess. 16, 6 times 16, 148.33. Okay, make sure you get that number, because that's the right number. Grams per mole. Okay, good. There's one more thing I need to mention here. Questions, anyone? 148.33, yes? Good? Questions? Just no? Okay. We always need, when we write down molar masses, so when we write down this, and by the way, you're quite often we're going to relate this to big M, just so you know. You don't have to put that in there yet, but that's going to be the big M, okay, the molar mass. That's what it stands for. We always have 2 decimal places when we do molar mass, okay? Always 2 decimal places. Even if it was like, for example, oxygen 16.00, you'll notice there's 2 decimal places, okay? Now there is one exception. I think lead has, it's 207.2 or something like that, or 0.1. I forget, I don't care. But we're just gonna pretend that the last one's a 0, okay? Don't worry about it. Just, we always write down 2 decimal places. So if your answer happens just by chance to work out to like, I don't know, I'm just gonna make up a number here. I don't think this is an even option, but let's say it's 247, that's it. We're gonna put 0.00, okay? We always record it to 2 decimal places, always, okay? Because basically what happens is, if you look here, there's 2 decimal places here, there's 2 decimal places here, there's 2 decimal places here, so there's 2 decimal places here, yes? When you're adding up stuff and everybody has the same scale, okay, which the periodic table is based on that, they're basically saying, hey, we know that this is accurate to 2 decimal places, so if it's accurate to 2, to 2, to 2, to 2, we're gonna go with 2 at the end, okay? So whatever that happens to be, we're gonna make sure we have 2 decimal places as an answer, okay? Significant digits, that's part of significant digits. It's different when you're adding stuff, okay? It doesn't go based on like, you know, if I looked at this, I'd say, well, that's 4 significant digits. It is, absolutely. But if we're adding it up, it depends on whose scale is the most accurate. And the scale on the periodic table is all 2 decimal place accurate, okay? And even if it's not, it is, okay, for our purposes. So we always have 2 decimal places. Make sense? Okay. You guys have a few questions there to practice right now. So I'm going to let you guys go ahead and do those for a little break here. We'll do those right now, and then we're going to move on. Okay. So let's take a little break here. You got some. So you guys can go ahead and do the practice there, 1A through N, with those compounds there now. Use a formula. So we're going to use this as part of a formula. We're going to get a little more practice here with this. And then once we get this done, I'll give you some class time to do this, and we'll see how far we get here. So we're going to convert between mass and moles now. So taking the number of, taking a certain mass, and we're going to convert that to a certain number of moles. And it's often useful for chemists to convert between amount and sample in moles and the mass of a sample in grams. In order to do this, we use a formula. The formula looks a little something like this here, okay? N is equal to little m over big M, okay? Looks like that. And I guess it's all labeled there for you, but N is the number of moles measured in moles. M is the mass in grams. And big M is the molar mass, which we just kind of worked on so far in this class today. And that stuff is at the bottom there, so you can fill in the blanks there for yourself. Say this actually. Like I said, there's going to be another keyword that goes with moles, and that word is called amount. So when you see a question that says, what amount do we have? That's talking about this stuff here, amount. Moles is another term for that. If I want to know what's the mass, I'll ask you what's the mass, okay, which is grams. If we want to calculate the molar mass, I'll ask you what's the molar mass. And if you see the word amount, or what is the moles or amount, that refers to N, of course, okay? So you need to know that. All right, good? Yes? Questions, anyone? So it's N equals little m over big M. That's the formula there. And we're going to use that in our example here. So our first example says, how many moles? So let's go through this question here. What letter am I looking for? How many moles? What does that refer to? N, okay? So I want you to go through and write in some letters here so you know what these variables are, right? That's what we have here. We have 3 variables. That means if you have 3 variables, how many do you need to know? 2 in order to solve the third one, yes? If you had 15 variables, you need to know 14, yes? To get the 15th one, right? So we have N. We have, what's this right here? 56.1 grams. What letter is that? Little m. Yes, the mass. So we're going to put a little m here, mass. Okay. And I'm looking for N. What letter am I missing? Big M. Well, look, can I get that from right here? Yes. Now, obviously, there's no number there, but we have to calculate it, right? So we're going to have to write out the formula of magnesium sulfate. And that looks a little something like this, magnesium sulfate. So somewhere, wherever you want to do this, Mg is a 2 plus, sulfate is a 2 minus. We're going to swap, drop, and reduce. If you do not reduce, if you put 2 and 2, what's going to happen? It's going to be wrong, is what I like to call it, okay? So we have to know how to write formulas, right? We cannot forget to swap, drop, reduce. We can't forget to do all that stuff. If we're talking about nitrogen triiodide, okay, we need to know what the formula is, because if we mess up the formula, guess what? This is all wrong, yes? Doesn't matter what you do here. So we're going to start with let's start here, I guess. We need to figure out a molar mass for this, yes? So molar mass, let's see. Let me grab a calculator here. So 1 magnesium, yes. 1 sulfur. You're going to look that up. Okay. And 4 oxygens. Okay. So, which is, of course, 64, but I'll put in 4 times 16, which is 64. Is that right? That looks right? 120.38? I think so. Okay. So we're going to put down here 120.38 grams per mole. Okay. Don't forget the units, please. That's important. Okay. And we're looking for what N, right? So to solve for N, well, do we have N by itself? Is N solved for? Yes or no? Is N isolated? Is N by itself? Yes. Can I just stick the numbers into this formula and get an answer? Sure. Okay. So we're going to write down the formula. We're going to say, okay, I got 56.18. That's going to go here, right? 56.18 grams. You cannot flip these numbers over, obviously. You get something entirely different. That's little m. You said it was. We just wrote it down. What's big M? We just calculated that. It was 120.38. Is that right? Did somebody else get that too? Make sure, because like I sometimes mess up. So make sure. Grams per mole. Okay. And we're going to divide those two numbers. That's what we're doing here. Yes. So let's see. What did I say? 56.18 divided by 120.38. Is that right? And I get this number here, yes? Looks like a lot of 6s and a lot of 8s. So usually what I do is I just do this, 666,888, okay? Okay, and this number is going to go on for a while here, but I don't really care, okay? What we need to do here, actually I probably should keep a little bit more here, and you might even want to do 8, 8, 8, and it just kind of keeps going forever here for a while there. Now, again, we want to look at eventually here, like I said, we're going to look at significant digits. How many significant digits are in my question? Somebody else. How many significant digits are in the question? What do you think? Chris? 4, okay? So we look at this here, yes? It's probably not going to be this. I'm going to tell you that right now. It's not going to be that number there. It's going to be 4 significant digits, yes? So how many should I have in my answer? I should probably have 4, yes? So to get 4, I'm going to have to do what? I'm just going to move this up to here. 0.4, remember, the 0 on the front doesn't count, okay? This would be 6, 6, that's 3. And then I look at this one here. There's my 4 significant digits right there. I need to round it up, yes? To 9. Okay, does that make sense? Good? Now, what are the units here? Moles, yes? So we need to make sure we write that down. We probably should have had that here, and we should have had that here. Okay? So we're going to circle it or underline it or something so I know that that's my final answer. Okay? Just like the game, TV show, or whatever. Is that your final answer? Who Wants to Be a Millionaire? That's what it was. You guys don't know that. You're too young. Never mind. It's okay. Is that your final answer? Yes. Okay. Good. Questions, anyone? Oh. Three. Oh, yeah, you're right. There's 3 6s there, isn't there? I wrote that down wrong. 6, 8. Yeah, you got to keep track of me here, people, because I'm getting old. So that's a 7 here then, yeah? Is that right? Yeah. Okay, my bad. Sorry. You got to keep track of me. I tell you. I'll try and. I was just testing you to make sure you're paying attention, and you were. Good. Yay. All right. Hey, look, I'm not perfect. All right. Good. Questions, anyone? Now, you have to understand kind of what's going on here. We're changing a mass into an equivalent amount, right? How many moles? Look, if I had 120.38 grams, now just watch, you don't have to do anything here, obviously, and I'd rather you don't do anything. But in fact, I'm going to do it in a different color here. If I took 120.38 grams, right, of this magnesium sulfate, and I divided these two, how many moles would I end up with? 1, right? Because it's 120.38 grams for every mole of this substance. Well, if I had 128.38 grams, I'd have a mole of this substance, right? All I'm doing is I'm just saying, well, how many moles do I have? What's the ratio here? Well, if I took instead 56, right, which is about, 60 would be about a half, yes? 60 out of 120 is about a half. So I got 56, so it should be a little bit less than a half a mole I have, yes? And that's what it turns out to be here, 0.4667 moles, okay? So that's all I'm doing. I'm just taking this number and converting it to how many moles. That's all, okay? I'm kind of getting a ratio here of basically, I don't have a full mole, I have this much. The chance of you having a full mole of something is probably not very good in a lot of cases, okay? A mole, as we can tell, you'd have to have 120 grams of this. 120 grams is a lot of stuff, okay? Like it's a lot, all right? So the chance of you having actually a full mole of something is probably not good. Is it possible? Absolutely. Is it a lot of material? 120 grams, 20 grams is a lot. That's what I usually do for bench curlings, arm curls. But maybe a bit more, 120 kilos. Thunder and lightning, very, very frightening. It's a song. Anyway, okay. Just kidding. It's 120 pounds. Sure. But 120 grams is a lot of material, so we probably don't have that much. Okay, just so you're aware. Even 56, by the way, is quite a bit. Okay, I mean, our scale, I don't even know if our scale would go that high, to be honest, because I don't know if it does that high. All right, good. All right. Now, how this works is we have units here, of course, and I don't know if I really want to get into this too much, but remember, when we divide numbers or when we multiply numbers, units should cancel out, yes? How do we end up with moles out of this, other than we know N should be in moles, right? Well, what happens when you take a gram and divide it by a gram per mole? What happens when you take a number and divide it by a fraction? So let's say you take 2 divided by 4/3. What do? You should know this from math class. If I took 2 divided by 4/3, what do I do? Yeah. Sure. What else could you do? Yeah. I know, usually we talk about you would multiply by the reciprocal is the key word. Remember that? Reciprocal. So I would multiply this by what? 3/4, yes? I flip that over, yeah? Okay. That's what's happening with this fraction here. So I'm actually going to grab a thing here. If we take grams and we divide it by grams per mole, okay, basically what I'm saying is we're going to take grams and divide it by grams per mole. What do? I multiply by the reciprocal. I flip it over, yes? Boom, boom, yes? And we cancel out the grams. We're left with moles. That's what you're doing when you take grams divided by grams per mole. That's how we end up with moles. It's not magic. It's not because N has to be moles. We know that. It's because they cancel out. Grams and grams cancels. We're left with moles, just like we did with moles and molecules stuff, right? Same deal. Okay. So that's how we're getting the moles. Okay. It's not magic. That's part of the formula. All right. Good. Let's look at example 2. Let's go. How many moles of nitrogen gas? So, how many moles? What are we looking for? N. Nitrogen gas, 34 grams. What's that? What's little m? Okay, so let's write that down. I encourage you strongly to go through here. What can I find from here? Obviously, I got to find big M, right? If I'm looking for N, I got to be able to find big M somewhere, yes? Molar mass, okay? So, what do I do? Okay, well, that's that. What does nitrogen gas look like? 2s, okay? So it looks like that, yes? Each one is 14.01, so 14.01 and 14.01 is 28.02 grams per mole. Again, periodic table, right? Big M usually comes from the periodic table, okay? I say that usually because sometimes we might look for big M, okay? We might try and figure out what compound it might be or something like that, 28.02. Same deal, okay? These examples are going to be similar because we're just starting you out on this, so we don't want you to confuse you too much. That goes there, of course, that's little m, 28.02 grams per mole here. And we're going to divide those two, and we should get, what did I say, 34. Let me try to turn this on again here. There we go. 34 divided by 28.02, 2 nitrogens, 1.2134 okay? And again, grams, we'll cancel with the grams, and we're going to be left with 1 over moles, which basically turns out to be moles, yes? Okay? Significant digits. How many significant digits are in my question? What number, how many did I give you in this question here? How many do we got? You said what? 3, okay? 34.0. The 0 is significant because it's not 34. I'm saying it's 34.0, so that's how accurate I'm being, basically. So that's important, okay? So if I'm going to do 3 here, I'm going to go 1.21, first 3. I don't need to round this one up, and I'm going to say moles, yes? 1.21 moles. We're going to circle it or underline it or something, or put a box around it so I know that that's your final answer. If you just write down a whole bunch of numbers and you want me to guess, I always guess wrong. I have this, I'm just not good at guessing. Yeah. Oh, because this is just a mass. This is just as accurate as this scale is. On the periodic table, it's different. That's a different scale. I don't know. This guy just weighed out 34.0. That's all. He's got the Walmart scale. I would probably go to 4 in that case because that's only to 4. Yeah. Having said that, we usually don't count this too much because that's not really going to be an issue. I wouldn't worry about that too much because we only do it to 2 decimal places on our periodic table, but technically it's probably more accurate than that, but we only record 2. So I wouldn't worry about that too much. Usually we go with the number in the question. So 3, okay? And then the last one here, aluminum nitrate can be used in leather tanning. How many moles of aluminum nitrate are in 25-gram sample? Why don't you go ahead and do that? Let's see how good you get here, how accurate you are. Is that right for the molar mass? Yeah, looking good. Okay. So again, 25 grams in this case, divided by 213.01 grams per mole. Grams and grams will cancel, of course. We'll be left with 1 over moles, which basically was moles. And we should get about a tenth or so, roughly here. Let's see. Oh, that's the wrong one. Let's go here. So what did I say? 25 divided by 213.01 is 0.117, yeah. And again, sometimes I'll use the dots because in the next lesson, this is not going to be our final answer. We're going to add on to this. But for right now, I just kind of do that. And we need 3 significant digits, yes, 25.0. So we need to maybe round accordingly here. 0.1173. So I just say, yeah, 0.117 moles probably would be a good answer here. We don't need to round up or anything like that. Okay, good. Questions? Yes, no? No? Okay. Now we're going to, obviously that's kind of repetitive and the same idea, but this is what you're doing for homework, okay? Now the next 3 examples are all the same as well, okay? However, now we need to talk about what if we have the number of moles of this compound? What mass is that equivalent to? So if I said, hey, here's a half a mole of this substance, go weigh it on the scale, how much would the scale read, okay? So find the mass when the moles are given. So it says here, what is the mass? What letter are we looking for? Sorry, well, what is it? Little m, okay? So we're looking for little m. What letter is that, or what does that tell me? N, okay, or otherwise known as the amount, okay? And calcium carbonate here, so what is that? Big M, okay? So we already know it's calcium carbonate. We can probably do that right now if you wanted to. Geez, I don't know, what is that here? So calcium is what? Help me out here. 40.08, is that right? Okay. Carbon and 3 oxygens. So that's 48, and that is 100.09. Yeah, that looks right. 100.09 grams per mole. Okay, so I got big M now. Okay. Again, periodic table stuff, right? Top right corner kind of deal. We got N. We got to find little m. So we're going to start here. How do I guess the first question is little, if I'm looking for little m, is it by itself? Is it isolated? No. Okay, so how do I do that? And don't say a triangle. I swear. How do we do that? Yeah. Sure, that's an acceptable answer. We're going to multiply both sides by big M. So I'm going to multiply this side by big M, okay? And I'm going to multiply this side by big M. Remember this saying, whatever you do to one side, you have to do to the other side, yes? Okay. Why do I do that? Because I'm going to get rid of this M. Look, cancels with this one, right? And now it's here. Do I have little m by itself on one side of this equation? Yes. Is it on the top? In other words, is it 1 over m or is it m right now? It's just m, right? So we're good, okay? So m is equal to n times big M, right? And if we do this right, okay, when all said and done, the units should cancel properly. And of course, what unit do I want to end up with here? Grams, right? We want to end up with grams, and if I did this correctly, that's what should happen, okay? Does that make sense? I'm going to show you another option here, and now it's up to you, okay? If you do this, have you guys ever heard of cross multiply? Cross multiply. So I would say what's n? N's the same as n over 1, yes? And I would cross multiply, yes? So 1 times m is m, okay? And n times big M is that, okay? Now that's not necessarily going to get you the right answer, but it's going to be a good place to start because everything's on the top. We don't have fractions anymore, okay? Same thing, doesn't matter, okay? I'm going to give you a quick little challenge here when we're all said and done here, but you can do that as well. That's called cross multiplication, okay? Anytime you have 2 fractions that are equal to each other, or basically a number, N over 1 is the same as N, yes? I just put it over 1 just so you can kind of see that you can cross multiply. You guys do that or no? Yes, no? No? Okay, well, that's an option, okay? Yeah, they with the same formula. So, what is the mass? Well, here's the mass. What's N? 2.50 moles, yes? That's the amount, otherwise known as the amount. What's the molar mass? We said it's 100.09, and I'm multiplying these two numbers together, of course, because that's what the formula tells me, N times M, right? So I'm multiplying those two together. When I multiply those two together, I get something. 2.5 times 100.09. 250.225. And my answer should be grams. Should it be? Let's see. Moles cancels with grams per mole. Yes? So basically it looks like this. Moles times grams per mole. That's what it means, right? Those two cancel, yes? Okay, so it looks like, yeah, we end up with grams. That's good. That's what we want to end up with. Significant digits, 3, yes. So I probably should have 3 here. So I could just say 250 would probably be just fine. 250 grams. That's all important. Yes, 250. Good? Questions, anyone? Okay. Let's kind of motor through a couple more here real quick. Is that okay? Everyone got that? Yes? No? We're good? Oops. Good? Yeah? No? Okay. Let's motor through the next one here. Same idea, right? Okay, here's my N. Silver precipitate. Silver precipitate, that's all it is. So silver solid, basically, yes. What is the mass of the precipitate? Make sure you go through and write down the letters in the question so we know what we have, what we don't have, et cetera, et cetera. And again, if I'm looking for little m, I got to know N and big M, yes? I mean, that's just kind of, that's how it works. 2 out of the 3 variables. I'm going to start with my formula. And this is not a, we always start with the formula, okay? We're going to show work. I want to see some work for today. We need to calculate big M, or sorry, little m is what I meant. What is the mass? To do that, up to you how you want to do it. Yeah, absolutely. You can multiply both sides by big M. Perfect. I like it, okay? That's going to cancel with that. And we're left with basically this. M equals N times big M. You can cross multiply if you want, okay? Whatever, if you want to do that. Again, same thing. M times 1, N times M, like so. Whatever, don't matter. Pick one, okay? Make sure you know how to do that, because we're gonna ramp it up here right away. 5 times 10 to the negative 3, that's the number of moles. So I'm going to put that right here. 5 times 10 to the negative 3 moles. Remember, my numbers don't really transfer over. Your sheet's fine, though. Okay. And silver, don't tell me this. I know this. I want to say it's 107.87. And my board just froze. That's great. 1.0787. Yeah, grams per mole. So we're going to put that in there. Let's see. This is really a bad time for it to freeze. Oh, yeah, kind of lost a little bit there. Let's see here. So we were here. Big M. 5 times 10 to the negative 3 moles. And I said 107.87 grams per mole. And if we multiply those two, okay, when you go to multiply these two, just remember that 5, and again, there's a couple ways you can enter this on the calculator, of course. You can either do 5 times 10 to the negative 3, like so, okay? Or, again, you can use that button, so 5.0 if you want to be accurate, whatever, doesn't matter really. E, and then we put negative 3, okay? And we're going to multiply that by 107.87. We should get 0.539, yes? Is that right? Correct? Yes? No? What did I say? 0.539 moles. How many significant digits? We only have 2 there, yes? Correct? 2. So we should probably have what? 0.54 moles would probably be my best answer in this case. Good? 539? No, yes, no? Is that okay? What? Did I screw up? Oh, grams. Oh. Say something. Grams. That's what I meant to say. Grams. Mass. This is what happens. Good? Okay, grams. Questions, anyone? Okay. Good. Last one here. 4.36 moles. N. What is the mass of dinitrogen tetroxide? And of course, dinitrogen tetroxide is my formula. Good little review. We haven't done this for a while probably. And I can find out some big M from there probably. Yeah, molar mass. Correct? Okay. So let's take a look here. Again, we're going to start with this. Okay. Multiply both sides by big M. That'll get rid of the little m on the, or the big M on the bottom, of course. And we're left with this. No. No. Mass. I just want to. I got a little thing I'm going to put here. It's just remember this point. I'm going to put something right here, and it's going to say a question. And when it says that question, you'll understand what I'm thinking right now. Okay. At this point. Okay. All right. Mass equals N times big M is what I'm trying to say. 4.36 moles. And dinitrogen tetroxide, that looks like this, yes? Hopefully you got the right formula. Again, if you don't have the right formula, guess what? You have pretty much no chance of getting this, well, you have no chance of getting this answer right? Dinitrogen tetroxide, 2 nitrogens in that. So that's 64 and 28, I got this. 64 and 28, 92.02, yeah? 92.02 grams per mole. And we're going to multiply those together. I don't think I can do that in my head today. I barely can write down the right letters for crying out loud. So chances of that happening aren't good. 4.36 times 92.02. And 401, I guess, yeah? Oh, come on. 401 is what I'm writing there. 3 significant digits, yes? So 401 grams, yes? Good? Okay. This is not going well, is it? 401, that's twice today already. 401 grams should be your answer there, yeah? Good? Questions? Good? Okay, write down 401 in case you don't have that. Okay, I'm going to take a quick break, but you guys can start working on homework. All the answers are on the worksheet. So you are going to show your work, yes? And you'll know if you're getting them right or not. Okay, quite often we're going to give you some answers now because, you know, there's no point in doing all the questions if you're doing them all wrong, yes? Or when you get one wrong, you're like, oh, well, what could I have screwed up on? Molar mass? Possibly, okay? Formula? Maybe, but molar mass? Probably. So go back and say, oh, well, I didn't get this right, or whatever. Talk to somebody, yep.
When you have a formula such as this, what little m equals n plus big M?
N times big M? Yes.
Can you do like big M times n?
Yeah.
Like reverse it?
Yep. Yeah, it doesn't matter. Okay. I'll be right back. I'm going to ask you one more question just for fun. Just, we have to be able to solve for formulas, right, for variables. So I just have this little quick question for you. This is called, by the way, this formula is called the mass amount. You'll often hear it referred to as the mass amount formula because it takes a mass and it converts it to amount, or it takes amount and converts it to mass. What if I asked you, hey, what's the molar mass of this compound? So let's say I gave you the mass and I gave you the moles. I want you to rearrange this formula to solve for big M. Go. Big M. Go. Don't hear. Okay, and this is not uncommon, but we do need to know how to solve for variables, yes? Whatever you want to, the first step is always, usually, is let's get stuff to the top. Let's get rid of fractions and more stuff like that. Now, it's not necessarily the first step, but, you know, you got to start somewhere. We're trying to isolate this variable here. So you might say, well, I'm going to multiply by big M, because this is what you told me before, and big M, yes? And I would get rid of those two, yes? So now we have big M, N equals that. We just rearranged the formula, and we've solved for little m so far, yes? Right? That's okay, though. Do you see any fractions left here? No. Okay. How do I, now you know this, how do I get big M by itself? No. I have to get rid of, how do I get rid of N? No. If it's M times N, how do I get rid of N? I divide by N. Divide by N. Your formula should be this. Yes? Okay. All right. The other option, of course, is if you're doing this, you can cross multiply. So, you know, again, we have, at some point, you're going to have this, right? I mean, that's still the given. You still need to divide both sides by N. We need to do the opposite, right? Big M is, look, doesn't that make sense? What do you measure big M in? I know we got to go up here right away, but listen, molar mass is measured in what? What are the units for molar mass? Grams per mole. Isn't that what you end up with there? Grams per mole? Yes? Okay. All right, have those questions done for tomorrow. Okay, again, the answers are there. I want to see the work. Okay.